Now, the written assignment, this is how the course will be graded. The 10 written assignments, they will cover 10 marks or 10% of the total mark for this course. Then our mid-semester exam will be 20% for this course. Then we will have our final exam covering 70%. Also, there will be short quizzes and tests on Socrative, depending on the availability of time. Whenever we will have a quiz or test on Socrative, you will have to log in as a student. So I will advise that you all download or you create accounts with Socrative. And when you are asked to, you have to log in as a student. You will be asked to enter a room name. The room name will always be Banning 374. And then you will be asked to enter your student name. So this is how the student name will go. Assuming your index number is 14TU2345 and your first name is Samuel, then this is how you enter your index number, like you see on the board. Okay, so please take note of this, because that is how I can see your paper and grade it. Okay. Any questions, please? Any questions? Hello.
Hello, sir.
Yes, madam.
Please, you mentioned about moving forward something. I would like to know if the class is always going to be online or we may meet face to face.
All right, thank you. So, you know, the mode of instruction, that is how we attend the class, is determined by the academic board. In this semester, the academic board agreed that we would have 60% online and 40% face-to-face. So even though the academic board has not made any provision yet for the face-to-face, I am very hopeful that we will definitely have a face-to-face session in this course. So kindly keep your cool. I am very sure that there will be a face-to-face session. Is that okay?
Yes, please. Thank you, sir.
You're welcome. Okay, are there any other questions before we start today's class? Okay, good. If there are no questions, then let's start the class. Okay. So this is the outline for today's class. We are going to look at what operating systems do. We look at how the computer system is organized. Then we will look at the architecture of a computer system. We will study some of the operations, how the operating system operates. We look at resource management. We look at security and protection. We look at virtualization. Depending on time, if we still have more time, then we'll continue with distributed systems, the kernel data structure, computing environments, and we'll mention a few of the free open source operating systems. This is the objective. At the end of the class, I'm expecting that as a student, you should be able to describe the general organization of a computer system and the role of interrupts. You should be able to describe the components in a modern multiprocessor computer system, illustrate the transition from user mode to kernel mode, discuss how operating systems are used in various computing environments, and be able to provide some examples of the open source operating system. Okay, now let us start our class. In 5 minutes, let's discuss this. Has any of you encountered any operating system before? let me call you by names. Has any of you encountered any operating system? Afrifa or Day, Emmanuel, if you are with us, kindly.
Yes, sir. I'm here, sir.
Okay, Mr. Afrifa, tell us, have you encountered an operating system before?
Yes, sir. Windows, sir.
Windows operating system.
Yes, sir.
Can you tell us what you used it for? What you use the Windows operating system for?
So actually, Windows operating system is the software. I'll say a system I use on my computer, which helps me to operate and use any other application on my computer, sir.
Okay. All right. Thank you.
You're welcome, sir.
Okay. Let's go to the person with index number 20043. 20043 at the end. 20043. Okay. If that person is not available, Frederica, if you're with us, can you please tell us if you have encountered an operating system before? Madam Frederica, if you are here. Okay, so let's assume Frederica is not here. What about Mr. Francis? Please, next time when you are logging in, I would prefer you log in with your full names, please. Log in with your full names, not your index numbers, please. Mr. Francis, are you here? What about Loretta? Loretta, are you here?
Yes, please, I'm here.
Okay, please, can you tell us, have you encountered any operating system before?
Yes, please.
Can you tell us which one and how you used it?
Please, Windows.
Okay.
Yes, so that's the operating system I use on my laptop. So it helps me to download other softwares and also to use Microsoft Word and other apps that I can use on my laptop.
All right, thank you. So can you tell us which of the Windows you are using?
Please, I'm using 20. Sorry, please, I'm using 2006.
2006.
Yes, please.
Okay.
Hey, Seth, I'm confused. I'm using Windows 10.
Windows 10. Okay.
Yes, I'm using Windows 10.
Okay. All right. Thank you. Windows 10, and use it to do your work. Okay.
Yes.
Great. Thank you. Thank you, everyone, for your contributions. Now we have seen and heard people who have used operating system one way or the other. I'm sure we have all sat in cars before, be it trotro, a taxi, or a private car. Now, tell us, are these computers? And if they are computers, do they have operating systems in them? If you take a car, a trotro by the roadside, do they have operating systems on them? What about the washing machines that we use in our homes? What about the printers that we see, the remote controllers, the toasters? What about airplanes? Do they have operating systems in them? Can anyone tell us? Please, if you feel like telling us, you can unmute yourself and share with us. Do you feel that these items or these components that I've mentioned, do you think they have operating systems in them?
Good evening, sir. My name is Richard.
Okay, Mr. Richard, please tell us. Thank you for coming.
Yes, thank you, sir. Yes, sir, I believe that they all have operating systems in them.
Okay.
This is because it's the operating system in them that enables them to communicate with the other devices.
other devices like?
Let's say when we take a car,
Okay.
we have a stereo set. That's the radio.
Okay.
Yeah. So it's the operating system in the radio that allows you to be able to change channels to other tunes or something.
Okay. All right. Thank you,
Yes.
Mr. Richard. Mr. Evans Asubontin, your hand is up. You can unmute yourself and tell us.
Okay, I believe that
Yes.
the operating systems in most of the devices we use. For
Okay.
example, when you use a car and then you go to the workshop, and there is a fault, and we want to detect the fault of the car, we sometimes put an adapter
Okay.
into the car, specifically like a plug, and then we communicate with the car so that it gives us every fault on the car. So by so doing, the machine that has the software and has been plugged into the car, with the help of the operating system in the devices of both the machine and the car, we can just communicate and just find the fault easily without stress. So I believe most of the time, operating systems are always working in our devices.
Okay. All right. Thank you for that. We also have Hamida Ashley. Please, you can unmute yourself and talk to us.
Hello, sir.
Yeah.
So I think that with the operating system is the software that brings these machines to life. So a vehicle is just a hardware. So operating system is what brings it to life, that makes the user able to use it. I don't know, I'm using tautology. Yeah, so it makes it so more efficient, and like the user can use it. If there's no operating system, the vehicle is nothing but just a hardware. Thank you.
Right. Okay, thank you, Hamida. Now, I want to ask a follow-up question. So, considering the fact that you mentioned that all the cars that we have are just hardware without the operating system, so let me ask you, that trot car, that old trot car with the door hanging and the driver finding it difficult to change gears, are you saying all those cars are computers and they have operating systems on them? Miss Hamida or Mrs.
So well, with the old cars, they are more of mechanics. I don't know how to explain it. We have the analog and the digital. So they're more the analog systems.
Okay.
I don't know if I'm making sense.
Right. Okay, thank you. Thank you for that contribution. All right. So I am hopeful that by the end of today's class, we will be able to tell whether these devices that we've mentioned have operating systems in them, like the televisions we have in our homes, like the remote controllers that we have in our homes. We are going to see by the end of today's class if all these devices have operating systems in them. Okay, so now let's ask ourselves, what is an operating system? Now, an operating system is a program or a software that acts as an intermediary. So I want to underline this word here, that acts as an intermediary between a user of a computer system and the hardware of the computer. Okay, so when we say someone is an intermediary, the person stands in between two objects. We have always mentioned that the computer only understands zeros and ones. What it means is that on board the computer, we have some devices like the capacitors, like the switches, like the resistors, like the transistors. All these are devices that understand two states, on or off. Okay, so in order to have A appear on your screen, when you press on the keyboard, A on the keyboard, In order to have A appearing on the screen, some of these capacitors have to be turned on. Some of them must be turned off. Some of these resistors must be turned off. Others must be on before you are able to get your A appearing on the screen. Now, as humans as we are, we cannot always go into the computer and be switching these physical hardware off. We can't be doing that. And so there is the operating system that stands in between the human being, that is the user of the computer, and the hardware. So this operating system is the one that interprets what we want to do to the computer, turns off the necessary ICs and transistors for us to get whatever we want to do. Now, in the design of the operating system, the operating system seeks to achieve these goals. One, to execute user programs and make solving user problems easier. So if you have any program that you want to run on your computer, it is the operating system that makes this possible. Not only does it make it possible, it also ensures that it makes it even easier to use. Like you want to do a calculation, you use the calculator. The work of the operating system is to ensure that the calculator is used with ease. It also makes the computer system conveniency. Now the operating system is even more convenient than ever. Now you can just speak and the operating system will be typing for you. Okay, now you can make gestures and the operating system will be acting on your behalf. These are some of the ways that the operating system makes the use of the computer convenient. The operating system also uses the hardware in the computer system efficiently. Whenever we mention efficiency, let me underline this word. So convenience, efficiency, and ease. Okay, these are the prime goals of the operating system. Whenever we mention efficiency, I always have this diagram in mind. Okay, this is a lever, this is a pivot, and that is a load. Okay, and then in this diagram also we have this is a lever, this is a pivot, and that is a load. Okay, if we name these two diagrams, this is A and that is B, which of these diagrams will we lift the load easier, assuming the load are the same? Which of these diagrams will we apply less effort in lifting the load? Who can tell us? Who can tell us? This is a little of physics. This is a pivot, that is a lever, and this is the load. If we want to lift this load, okay, which of these two diagrams, we have A here and that is B, which of these two diagrams will we apply less effort? Is it diagram A or diagram B?
Diagram B.
Diagram
B. Okay, so can you please explain why B?
So with B, the position of the pivot is somewhere in between the lever.
Okay.
It will require less effort to push it to lift the load. But in diagram A, the pivot is far away from, let me say, the midpoint of
of the lever.
Yes, of the lever. So it will require more energy to lift it, to balance it out.
Okay, please, is there anyone here who does not agree?
Yes, sir.
Yes.
Yes, sir.
Okay, so you don't agree with what our friend just told us?
Yes, sir.
Okay, please, can you explain?
Okay. Taking consideration diagram A, you can see that the effort is having a much space or a wider space. That means
Okay.
raising the load is going to be easier
Okay.
than in diagram B,
Okay.
where
All
the
right.
pivot is rather in the middle.
Okay.
So comparing the two, you can see the A is much easier or less effort than B.
Okay, good. Thank you, gentlemen, for all your contributions. All right. So indeed, there will be very less effort in the diagram A than the effort compared in diagram B, because here the pivot is right at the tip where the load is. Therefore, it will be very easy. You apply less effort in the A than it is in B. Now, whenever we talk about efficiency, this is what we mean. Okay, apply less effort, but making a greater impact or having a greater output. So that is efficiency. Okay, now these computer systems that we have these days, we have expensive and sophisticated hardware components in them. Now we have i3, we have i5, we have i7, we have Pentium 4, Pentium whatever. All these are expensive hardware equipment. Now, if we don't have the operating system, we cannot make an efficient use of these expensive gadgets. Okay, so we are going to see how the operating system helps us in efficiently using these hardware components. All right, so these are the three core goals of an operating system: ease, convenience, efficiency. All right, if there are no questions, let me clear the screen and move on to our next slide. Now, if you take a computer system, the structure of every computer system, there are four main components. We have the hardware, we have the operating system, we have the users, and the programs. Okay, let's use this diagram. So, the hardware, as we all know, are the physical components that you can find on the computer system. Then we have the software or the system applications. These are the softwares that we use in solving our daily problems, like the compilers, like the assemblers, like the text editors, like Word documents, PowerPoint, like games, like database systems. All these are application programs. Now, the user is the one that is using these application programs to solve their problems. But we cannot communicate with the hardware directly. Therefore, the operating system, as you see in the diagram, serves as an intermediary between the user and the operating system. This is the abstract view of the operating system. Now, let me come here to explain something here. When we say the users of an operating system, please, who are they? Can anyone tell us who the users are? We have here the people like you and I. Then we have machines and other computers. Who are the machines? How do machines use the computer system? Can anyone tell us, please?
Could you please repeat the question, please?
Hello? Hello, are you there?
Hey, could we come again with the question?
Yes.
Okay, what I'm saying is,
Hello?
okay, thank you. I can hear you now. Rosemary, you want to say something?
I think please repeat the question again,
Okay,
please.
so the question is, if you look at my slide right now on the screen, when you
Right.
divide the computer into components, there are four components. We have the hardware, operating system, the application programs, and the users. Under the users, we are saying that a user of a computer system can be people like you and I. We also have machines and other computers. So how do machines, when we say people are using computers, we all understand. How do machines use computers? Can you give us an example of a machine that is using a computer?
An example,
Mhm.
let's say
An example.
an
A car.
example.
Yes. Rosemary, please.
Another example would be like an exercise machine.
An exercise machine.
Yes.
Okay. Like the ones we see in the gym.
Like a treadmill.
Okay. All right. Thank you. Thank you, Rosemary. Bosompim, you were saying something.
A car.
A car. Okay. So how does a car, you see, we are talking about the machine as a user. So how does the car use a computer system?
So once again, I'll still stick with the stereo set example.
Okay.
Yeah, it's computerized.
Okay.
So the car itself being a machine, it's using that computer or that system.
Okay.
Yeah, that's what I can say.
All right. Okay, good. All right. Mr. Appa, your hand is up.
Yes, sir.
Yes, please continue.
So we can look at a power plant for like generating electricity for an industry or a house.
Okay.
It can be programmed in a way that as soon as the main electricity goes off, the power plant turns on automatically. It's using the operating system to function here.
Okay. All right. I'm glad you have wonderful examples. I am hopeful that we are all going to enjoy in this class. So we are talking about machines that act as users of a computer system. Yes, Mr. Enos, your hand is up.
Yeah, hello, sir.
Yes.
I wanted to ask, can artificial intelligence be part of something like that? Like, let's say your phone is communicating with your air conditioner for it to turn on.
Okay. All right. Okay, thank you. Yes, that is also a wonderful example, like an artificial intelligence system that detects or senses the environment based on based on thresholds. The artificial intelligence device will determine or will decide on what to do. These are all machines that are available. But in this example, I was looking at a machine as a user that uses the computer. I will come back to this question in the later part of this class, and we will all discuss it again. But for now, thank you all for your wonderful contributions. Now let's go on and look at and is an operating system. Okay, sorry, what do operating systems do? Okay, so the operating system, like we have all agreed on, is the one that stands in between the user and the computer system. So it is the one that provides the means for proper use. And notice that I have highlighted the word proper use. That means that without the operating system, the resources on the computer system will not be properly used. Yes, you have a sophisticated, what do you call it, processor on your computer. You have a computer system that is purchased at how many dollars? Millions of dollars, okay? But if you don't have an operating system on the computer system, you will not be able to make proper use of these gadgets. We will come to that. So here, the operating system can be likened to a government. What do governments do in a country? The government itself performs no useful function. It means that a government without people or a government without a nation cannot do any useful work. It doesn't perform any useful function. Okay, a government simply provides an environment, or the operating system simply provides an environment within which other programs can do useful work. Okay, so the government is the one responsible for making sure that some projects are undertaken. For example, we need roads, and the government will see to it that the road is constructed. We need school, then the government will see to it that the school is constructed. So the government provides an environment for people to create or do this project. In this case, the government or the operating system becomes a resource allocator. Okay, there are resources in the computer system. We have the keyboard, we have the input devices, we have the output devices, we have the display. All these are resources that the computer has. Operating system depending on what the user wants to do, will allocate the resource for the computer to be able to do that task. Okay, just like the government. Okay, we want to create or we want to make roads, the government will allocate money, funds for the roads to be constructed. Okay, so the operating system is nothing but a resource allocator. It is also a control program. After it allocates a resource for a particular task to be accomplished, it also ensures that the task is indeed ongoing. It monitors the flow or the control of that program from start to finish. So the operating system is also a control program. Okay, so this resource is being used by this. Okay, so if anybody needs that resource, you wait. After this program has finished, it will allocate the resource to this. All these are the work of the operating system, and everything it is doing is to make sure that the hardware resources are used in an efficient manner. The computer that you bought with your hard-earned money, it is the operating system that ensures that the resources on that computer are used in an efficient way. That is basically what the operating system does. Please, do you understand what is going on here? That means that without the operating system, we cannot use the computer system in an efficient way. Okay, now let's go on. What are the goals of the operating system? We have already seen a snapshot of the goals. The first is to simplify the execution of user programs. Okay, we talked about the easiness of the operating system. Okay, the second one is that the operating system uses the computer hardware efficiently. We talked about the efficiency. Okay, this is done by allowing sharing of hardware and software resources. So that is why you can have your computer playing music. You can still be doing your Microsoft Word assignments, and you can still be browsing or surfing the internet. You can still be watching your movies. The operating system ensures that all the resources are used in an efficient manner. The operating system also ensures that applications are portable and versatile. What are we talking about? Today, we have so many operating systems. We have the Microsoft operating system. Microsoft alone has Windows 10, Windows 8, Windows 7, Windows XP, Windows 2000, Windows blah, blah, blah. All these are Windows operating systems. Then we have the iOS. The iOS is from Apple. That is the iPhone. Then we have the Mac OS, also from Apple. That works on the Macintosh or the Mac computers. Then we have the Linux. We have the Android. All these are operating systems. Their work is to ensure that software are portable. What do we mean? We mean that even though a software was developed on Windows 10, we can still take it to Windows 8 machine and it will still work. Even though a software was developed on Windows XP, we can still bring it to Windows 10 machine and it will still work. That is because the operating system ensures immediately you double click on a file, the operating system will gather all the necessary resources in order to make that software or application work on your computer. So the operating system makes software portable and versatile. It also provides isolation, security, and protection. Now, what is isolation? Now you will be playing your music. At the same time, you will be doing your assignment on Microsoft Word. What is happening? The operating system makes the music. So this is your VLC file that you are using to play your music. This is your Word document that you are using to play your document. The operating system will make the VLC feel that it is the only application using the processor or the CPU. It will also make the Word document feel that it is the only application that is using the CPU. So even though there are multiple applications running on your computer, the operating system ensures that there is isolation. There is no conflict between these two applications. Okay, we will come and see, in the course of this program, we will see how the operating system does that. Operating system also provides security. What is security? Now, we don't want the memory location of this VLC to be overwritten by the memory location of this Word document. So even though you have so many programs on your computer, the operating system ensures that these programs run peacefully. Okay. Number two, the operating system also ensures that unauthorized users don't get access to files that they are not authorized to. Okay, so if you have your file, if you have your computer, I'm sure you have come across the login screen before. This is one of the security mechanisms that the operating system uses to ensure that your documents are secure. Okay, all these are provided by the operating system. And it is making this even more convenient by allowing you to now use modern technologies like the iris. You can use your eye to log in. You can use your thumb to log in, thumbprint. All these biometric login or security system are mostly provided by the operating system to ensure the security and protection we are talking about. Then the operating system also improves the system reliability. Your system or your computer is reliable because of the operating system. How does the operating system do this? It starts with the error confinement. Now, if you have used the iOS before, that is, if you are using an Android phone or even the iPhone, iOS, now you notice that from time to time, if you are running WhatsApp, your WhatsApp will abruptly go off. If you have seen that before, please, has anyone encountered that before? While you are using WhatsApp on your iPhone, it will simply go off. Then you have to go and restart it.
Yes, that's true.
Yes, yes.
Yes, sir.
Okay, very good. So, okay, thank you. So whenever you encounter that problem, know that the operating system, that is the iOS, has actually saved you from a fatal error. Okay, there could be a system crash. There could be any fatal consequences, but the operating system will shield this error. It will confine the error by just exiting the WhatsApp application so that you can just go and run it again. So in the same vein, all operating systems actually protect our computers from fatal errors. Some of the error may be the consequences of the error may be enormous, but the operating system will conceal it, something that we call the encapsulation. It will hide that so that we don't feel, and then the operating system will simply send you a message, an error has occurred. Example of such messages are error 404 when you're trying to view a page on the website, on the internet, sorry, and the page is not found, you get error 404. These are all messages that are sent, friendly messages that are sent to us to conceal the actual error that has occurred. Operating system is also fault tolerant. Now we have computer systems that are using multiple processors. Okay. Now, in the event that some of the processors fail, the operating system is able to rely on the processors that are working to complete your job for you. Suppose there are 3 processors on your computer. All these processors are working in tandem to complete a particular task. And then all of a sudden, one of the processors go off. There is a problem with the 3rd processor. The operating system must reorganize itself and then put these tasks on these 2 available processors to complete the job. All these are done at the blind side of the user. So you will be using your phone or your computer with these going behind the scene, and you will not, the operating system will not make you feel or even realize that there was a problem in the execution of your process. So it makes our computer system very reliable. Another aspect of the reliability is reconfiguration. You know, from time to time, you realize that your computer has updated itself. Maybe if you're using iOS, you see your iOS has been updated. If you're using Android, you will see that your Android operating system has been updated. By the time you wake up in the morning, your phone has updated itself. By the time you wake up, your computer has updated itself. Now, in the process of updation, files are copied from one location to another on your computer. Files are downloaded from the internet and installed on your phone. That is the process of updates. So all these file reconfiguration or system reconfiguration are done behind the scene. The operating system does not bother you with the copying of files from one location to another. That is because it is trying to achieve the goal of reliability. So these are what the operating system does for us. Okay, I hope you are with me. Are there any questions? Are there any questions?
None yet. No question yet.
All right. Very good. If there are no questions, then let's continue. Okay, so let's try to define an operating system. You see, if you read many books, you get many definitions for operating system. There is no completely adequate definition for an operating system. But in all the books, in all the definitions that you come across, there is a common one. That is that the operating system is the one program that is running all the time. Every time you see your computer system on, the operating system is running. So take your phone. If you're using Android, if you're using iOS, if you're using Windows, every time your phone is on, you should understand that the operating system is running. And some of us, we hardly turn our phones off. The phone can be on for about a year without turning it off. And this implies that your operating system has been running for a year without going off. That is the operating system for you. Now, the operating system that you see, if you're using Android, for example, there is the operating system. Let's use this diagram to illustrate the operating system. There is some part of the operating system that is the core of the operating system, okay? Basically called the kernel. Okay, so if the operating system was a car, the core of the car is perhaps the engine. Okay, so we will say that the operating system is the core, sorry, the kernel is the core of the operating system. Now, in addition to the kernel, there are other applications that make the operating system work efficiently or conveniently. If you take a car, and in addition to the engine, there are other utilities or there are other components that make the car even more
Hello?
convenient. Yes. Yes. Do you want? Okay. All right. So if you take a car, in addition to the engine, we have the air conditioning services. Okay. We have the lightning service that helps you to see in the night. We have the radio or the, how do they call it? The entertainment unit. All these are there, but the core of the car is the engine. In the same way, if you take an operating system, the core of the operating system is what we call the kernel. Along with the kernel, there are two other types of programs. We have the system program. Okay, so what are these system programs? These are the programs that come with the operating system. Okay, the systems, they come with the operating system. They are associated with the operating system, but they are not part of the kernel. Now, if you have installed an operating system before, you know that there's a program called Notepad. Let's take Windows. Every time you install Windows operating system, you a Notepad. You also get the calculator. Okay, you also get what we call the word pad. All these are system programs. They come with the operating system. Now, we also common systems program is the command prompt. You know, every time you type CMD, you get a command prompt. Excuse me, please. All right, thank you. So we have this command prompt that comes with the operating system. These are called systems programs. They cannot do without the operating system. Sorry, they cannot do without the kernel, but the kernel can do without these programs. They are only, they're only shaped with the kernel just to make the user feel a little more convenient. Like you want to type something, you can use the notepad. Like you want to execute commands, you can use the command prompt. Like you want to compute some numbers, you can use the calculator. These are there to make the operating system a little more complete. But the core part of the operating system is what we call kernel. Then we have the application programs. These are programs that are specially designed to solve specific problems, like WhatsApp. WhatsApp is an application program. It is designed to help in communication. We also have something like Facebook. Facebook is also an application program. It is designed to help people connect on the social media. We have applications like games. What games are we familiar with? Like the Temple Run, that is a game. We also have the Subway Surfers, that is a game. Those are application programs. These are specially designed applications that are used to solve specific needs. They do not come with the operating system. So please note the difference between system programs and application programs. These system programs, they come or they ship with the operating system, but the application programs are designed specifically or specially by programmers. Okay. All right. Please, any questions?
Okay, sir.
Yes.
Please, I'm a bit confused about exactly what the kernel does.
Okay. So kernel is the heart of the operating system. Okay. Kernel is the heart of the operating system. We will go into the kernel later, but I likened the kernel to the engine of a car. If you take a car, okay, the core component in the car is the engine, right? You can have your air conditioning running perfect. You can have a perfect air condition, brand new air condition, new condenser, new whatever it is. You can have correct lighting system. You can have correct seats. If your car does not have an engine, the car is not a car, right? Are you with me?
Yes, please.
Good. So
Yes, sir.
good. So in the same way, if you take an operating system, it can be broken down into two parts. We have the kernel, that is the heartbeat of the operating system. That is the one that actually does the communication on the hardware. And then we have the systems programs that are there to sort of ease the user, to make the user feel at home, because we cannot interact with the kernel. We will soon see what the kernel is all about. So if you take an operating system, there are two main sections: the core, that is the kernel, and the systems programs. Then after the operating system has been installed, you can now focus, or you can now install application programs like WhatsApp on our phones, like Facebook on our phones, like Temple Run on our phones, like Word document on our computers, like games. All these are application programs that people sit down to develop. Please, are you clear now? I mean, is it clear now?
Yes, yes, please.
All right, thank you. If there are no other questions, I'm going to clear this board and we go on. Okay. Now, if there are no questions, then let's look at the structure of a computer system. Okay, the structure of a computer system. If you take every computer system, okay, you have one or more CPUs. By this CPU, we mean the processor, the main processor of the computer system. Okay, so if you take any computer system, you have the CPU. CPU can be 1, can be 2, it can be 3. Okay, and then you have some controllers, like the disk controller. The disk controller is responsible for all the disks that you use, like the hard disk, like the floppy disk, like the SATA drive, like the SSD. All are connected to the disk controller. Then we have the USB controller. This USB controller is in charge of all the USB devices that you connect to your computer, like the mouse, the keyboard, the printer, and the likes. They are connected to the USB controller. Then we have the graphics controller or the graphics adapter. This is also in charge of the display. Like if you have HDMI adapter on your computer, that HDMI is not a USB device. It is a graphics device. So it is connected to the graphics adapter. Okay, your screen is connected to the graphics adapter. If you want to use a projector, it is connected to the graphics adapter. So these are the controllers that are used to control the various peripherals on the computer system. Now, if you look at this, all these are able to communicate with the CPU. So if the CPU needs any disk, it will come to the disk controller. If the CPU wants to communicate with any of the USB devices. It will communicate to the USB controller. So you see, the CPU does not directly communicate with the mouse. The processor or the CPU does not directly communicate with the printer. It does so through the controllers. Okay, so like you have the president of the nation, currently Nanado. If Nanado wants to talk to the people of Eastern region, he will talk to them through the Eastern region minister, Eastern regional minister. If Nanado wants to talk to the people of Greater Accra, he will do so through the Greater Accra regional minister. So these regional ministers, they are the controllers. And through them, Nanado is able to reach the people of Greater Accra and Eastern region. That is what these controllers do. Through these controllers, if the CPU wants to communicate with any peripheral, it does that. The communication is done through what we call the system bus. The system bus is nothing but the communication channel, okay, the medium through which the communication happens. Okay, so the CPU will use the bus to go to this controller. It will use the bus to go to the USB controller and all the other controllers. Notice also that we have the memory. This memory is the random access memory. Okay, this allows all these controllers, and the CPU to share or access the memory. Okay, the memory is shared by all these controllers. So this is how a computer system is organized. If there are multiple CPUs, suppose our computer has 2 or 3 CPUs, the CPUs will be like that. So imagine currently our computer has 2 CPUs. Okay, it will be communicating through the same bus. That is what happens. Okay, great. Let's go on there. Let's see how our operating systems operate. How do you get your computer to operate your operating system? Or how do you get your operating system to come on when you turn on your phone, when you press your computer? How does it work? So we know that every computer system has a button, one way or the other, or a switch that is used to turn it on. So on your phone, when you press and hold the power button, your phone comes on. On your computer, mostly it is a button that you press or a switch that you turn on. However you turn on your computer, when the computer starts, it runs an initial program called the Bootstrap. Let me bring to your notice what this initial program is. If you have a Samsung phone, for example, when you turn on your phone for the first time, you will see the word Samsung, okay, with some ring around it to be blinking for some time, okay, indicating that the phone is a Samsung phone. If you are using an Apple phone, for example, when you turn on, you see an apple whose half has been eaten, telling you that you are using an Apple phone. If you're using Infinix, you get a logo, an Infinix logo. If you're using a computer and it is a Dell, you will get Dell. You see Dell will be displayed. If it is HP, HP will be displayed. If it is Lenovo, Lenovo will be displayed. And even sometimes on the computers, you can press, when you immediately you turn on your computer, you can press some functional keys like F2, like F8, like F10, like F12, depending on the type of computer you are using. These functional keys will even bring some settings that you can work with. I'm sure you have come across that.
Yes, sir.
Yes.
Yes,
Yes.
sir.
All right. So that initial program, that is not the operating system. At that time, the operating system has not loaded yet. What you feel or what you see at that time is what we call the bootstrap. Okay, this bootstrap is a software that was put on the computer by the manufacturers. So if your phone is a Samsung, it's a Samsung manufacturers, they put that software, that bootstrap there. Okay, if you are using Lenovo, it is the IBM people or the manufacturers of Lenovo who put that bootstrap there. It allows you to communicate with the computer system, even in the absence of an operating system. This bootstrap is stored somewhere on the computer's memory at a place that cannot be deleted. Okay, that place is called a read-only memory. So the bootstrap is stored in a read-only memory so that that will not be deleted even if you format your computer. Some of them are also stored on an electrically erasable programmable read-only memory, an EEPROM. Okay, so this bootstrap that are stored in the read-only memory is known as the firmware. So when you turn on your phone, that initial bootstrap, that initial logo that appears is called the firmware. Same thing for your computer system. Okay. Now, when this bootstrap loads, remember when you install the operating system, your operating system is stored on the hard disk. If you have 128 GB of memory on your phone, your operating system is stored in the 128 GB memory location. If you have 64 GB, your operating system is in the 64 GB. So at the time of the bootstrap, the operating system will still be lying in the hard disk. So now after the bootstrap loads, the bootstrap will now go into the main memory and load your operating system, whether it is Android or Windows 10 or iOS. Your bootstrap will go and load that operating system into the main memory. It will go to the hard disk, that's your 128 GB. It will load your iOS operating system. It will load it from the hard disk into the main memory. Okay. When it loads it into the main memory, then the operating system will begin to execute. The first process the operating system will execute is called the init. The first process that the operating system will execute is called the init. So if you are using a computer, for example, you will see Dell or you see HP. It stays on the screen for some time, and then you see Windows 10. By that time, the bootstrap has copied Windows into the main memory, and Windows 10 has begun executing the init process. So this init process will bring the operating system to life. Then it will take you to the login screen. If you have a login, it will take you to your login screen. You notice that when the operating system or when the computer system gets to the login screen, it will be there waiting for your input. It is a mobile device. It is waiting for your password, right? Nothing will happen if you don't enter your password. The password screen will remain on the computer. Sorry, the password will remain on the computer screen for as long as you don't touch it. True or false?
True.
Okay, very good. So that is the init process. So you see that it is after you enter your password or on your phone, you touch the fingerprint sensor, that you go away from the init to the desktop or to the next process of the operating system, which we will talk about later on. So you see that until you perform an event on the operating system will not do anything. If it is a phone, it will be there and you see that the screen will go off. It will go to sleep mode. If it is a computer system, it will be there for some time. If you don't touch the keyboard, if you don't move the mouse, if you don't click the mouse, you see that the computer will also go to sleep. So we say that the operating system is an event-driven software. The event is nothing but the pressing of the keyboard, of the keys on the keyboard, or the moving of the mouse or the click. Please kindly mute your mics for us. Mr. Nicholas Adujamfi, kindly mute your mic for us. Thank you. All right. So we say that the operating system is an event-driven software. That means it will continue to remain on your screen until an event has occurred. And these events are the keystrokes or the mouse move or the mouse click. If you have done Visual Basic programming, I'm sure you know these events that I'm talking about. The mouse click, the double click, the key down, the key up, the key down, sorry, the key press. All these are events. So your operating system is an event-driven software. Good. Now, let's look at this. So we said that the operating system will be lying idle. Suppose you have turned on your computer. This is your operating system. This is the timeline starting at 0. The time the operating system executes the init, operating system will be doing nothing, sleeping until something happens, until you click a key. Sorry, until you press a key or you click a mouse button. So at this stage, whatever the operating system is doing has been interrupted, right? So when you press a key, the operating system will come and determine what you want to do and it will act accordingly. Okay, so that signal sent to the operating system is called an interrupt because it interrupts what the operating system was doing. At this time, it was sleeping, assuming your phone screen is off, and all of a sudden you press the power button or you press the home key. Then you see that operating system will come back to life. Your phone will come back to life. So at this time, it has been interrupted. So that signal that is sent at that time is called an interrupt. These events that we say the operating system accepts can also be called an interrupt. Okay, so when the CPU is interrupted, it will stop whatever it is doing. So at this point, it was sleeping. So let me just write S. Your screen was off, your phone was sleeping. So when you send an interrupt by clicking a mouse or by pressing a key, the CPU will stop whatever it was doing and immediately transfer execution to the address where the service routine for the interrupt is located. So the operating system will determine what interrupt it is. Maybe this interrupt is telling the operating system to make a call. So the operating system will transfer control to the service routine where making calls are located. Okay, operating system will go to that service routine and then follow the instruction here to make the call. If the if the interrupt is telling the operating system to take a selfie, the operating system will transfer control to the service routine for taking pictures to the camera. Then whatever you want the camera to do will be done. Okay. After you are done with your calls or taking of the pictures, your call will now notify the operating system that I am done with what I called you to do. So another interrupt is sent to the operating system. Then the operating system will continue with its sleep. So if you've noticed, after you do whatever you want to do with your WhatsApp and you close the WhatsApp, after a brief moment, your screen will go off again. So the operating system will continue what it was doing. Let me give you another example. You notice that when you are playing music on your phone, the volume will be, let's say, 40% volume. As your music is playing, if a notification comes, say, from WhatsApp or from Facebook, what happens? You see that your volume will drop from 40% to somewhere 30%. The volume of the music will drop, and then your WhatsApp notification will sound. After the sound, then your volume is taken back to 40%. Please, have you noticed that on your phones?
Yes, sir. Yes, sir.
Very good.
Yes, sir.
Very good. So that signal that is sent to your Android or your iOS is what we call an interrupt. Okay. So when the CPU receives that interrupt, it will send control to that location where the interrupt is, and then it will perform. So what it does is that it notifies you that there is a message from WhatsApp. So it will sound. And then once it is done, control will go back to the CPU, and the CPU will now resume or take your volume back to 40%. Okay, so after the interrupt service routine executes, then the CPU resumes the interrupted computation. So you are playing music, the CPU will resume the playing of the music. If the screen was sleeping, the CPU will resume the sleeping of the screen. Okay. Interrupts transfer control to the interrupt service routine through an interrupt vector. This interrupt vector contains the addresses of all the service routines. So every interrupt that comes, there are several interrupt routines. Okay, so like I said, this is for making call, this is for taking selfie, maybe this is for browsing, this is for doing that. So whenever the interrupt comes, there is a vector. That vector will contain the address, and that address will point to these interrupt service routines. So like the GPS telling the CPU what to do. So based on the GPS address, you will route to the right interrupt service. Okay, so that is what we call the interrupt vector. There is an address, or there is a location that tells the CPU where to pick the interrupt service from. Okay. Apart from these interrupts that I just mentioned, we will soon look at the types of interrupts. There is also another interrupt called exception. If you have done Java programming, by now you know what an exception is. Exception is an error, okay? Any deviation from the normal flow of a program. If an error occurs, the error or the program will also notify the CPU that, look, I was sent to go and buy something from where? Circle, but I did not get to Circle. So to tell my mother that I couldn't finish the job. That is an exception. It will also notify the CPU, and the CPU will do all the necessary damage controls. Maybe a resource was allocated to that service. Maybe a memory space was allocated to that service. Maybe a hardware was allocated to that service. When that service terminates, if it is not able to complete its job, it has to inform the CPU so that the CPU will take over the memory that was allocated to it. The CPU will now clear the memory location it was occupying. So when an exception occurs, that exception also throws an interrupt to the CPU. Okay, an exception can also be called a trap. Later in the course, we will look at exceptions in detail. So exception is a software generated interrupt that is caused by either an error or a user request. Now, if you understand what I am saying, let's go back to this slide. Now, we said here that an operating system is event-driven. That means that operating system will always wait for an event to occur before it will act. Some of these events are key press, key down, key up, mouse move, mouse click, and all that. Now, we are also saying in this slide that these events are nothing but interrupts that will interrupt the normal flow of the CPU and ask it to do something. So if an event is the same as an interrupt, then if the operating system is an event-driven software, then we can also equally say that the operating system is interrupt-driven. Do you all agree?
Yes,
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 sir.
yes.
Yes, sir. Yes, sir. Yes, sir.
All right, thank you. So the operating system is an interrupt-driven software. That means the operating system will continue to remain idle until an interrupt has occurred. Good. Then let me clear my screen so that we can go on. Good. Please, at any point in time, if you have questions, you can always ask so that we know where we are. All right, now let's look at this timeline to further illustrate the interrupt that we are talking about. This is the execution. This is the normal flow of the CPU. All at this point, the CPU has nothing. Mr. Asubontin, you have a question. You've raised your hand. Mr. Evans, you've raised your hand. Is it a question or a contribution? Or is a mistake? All right, thank you, Mr. Evans. All right, so this is the CPU. It's a normal execution. Okay, let's assume it is sleeping. Then at this point, you press the power button or the home key. That is an interrupt. So the CPU will now take control. It will now extend control to the interrupt vector where the service routine is located, whatever you want it to do. Maybe you want to take a selfie. So it will come here, shoot the selfie. So this is an interrupt, IO interrupt, input output interrupt process. So the CPU will process that interrupt. After it has completed, control will be given back to the CPU. And then the CPU will again continue whatever it was doing. So maybe at this point it was playing the music, and then the Facebook or the WhatsApp notification came. So the interrupt will go. What does it want? It wants to notify the user. So it will notify the user by ringing the bell or by making the sound. After the sound, it will go back to the music and the volume will be increased. So this is a timeline that is further explaining the interrupt that we have just talked about. This is also the same thing at this point. The input. So here there has been an interrupt, an IO interrupt request. So at this time, the IO will also be executing. It's basically the same thing here. Okay. All right. Now let's see the interrupt handling. Okay. So we said that when the CPU is interrupted, Mr. Edmond, you've raised your hand.
Yes, sir. Please, I was hoping if you could go over the diagram again, I beg.
The timeline.
Yes, please, sir.
Okay, good. Let me clear the screen then. Okay, so this is to illustrate the common functionality of the interrupt that we have talked about. Now, we said here that when the CPU is interrupted, it will stop whatever it was doing and immediately transfer execution to the address where the service routine for the interrupt is located. We have seen examples of interrupts as maybe taking a selfie. So I'm going to use S for the selfie, or maybe making a call. So I'm going to use C, or perhaps doing something else. These are interrupt routines. There are locations that these interrupt routines are stored. Assuming you are in a room, you are in an institution, these are stores. In this store, you have item A. In this store, you have item B. In this store, you have item C. So when an interrupt occurs, the CPU will determine what type of interrupt it is. And based on the type of interrupt, these are stored at these locations. So if this interrupt is looking for item A, then control is sent to this location A. Okay, whatever is here is executed. So that is what is happening here. So control will go, the CPU will stop whatever it is doing at this point. All this while it is doing this. When the interrupt occurs, the CPU will stop. Then it will transfer control to the location of that interrupt routine. Then whatever is there is executed. So whatever is there in this location will be executed. After its execution, control will now go back to the CPU so that the CPU can resume whatever it was doing. This is the timeline that further explains these interrupt functions, right? Please, is that okay now?
Yes, sir. Much
Yes,
better.
sir.
All right. Madam Ashley, you've raised your hand.
Yes, please, sir.
Okay.
So please, can you explain between interrupt and also allocation of resources by the operating system for certain jobs? Okay. Does that mean that when there's an interrupt, there's been a reallocation or allocation of like resource for that particular task, and it will complete and it will go back? Or I want to understand that aspect. Thank you.
Sure, you're welcome. Okay, so let me tell you all. My computer, my light just went off. I have a UPS that is going to sustain us for at least 30 minutes if the light does not come. But you will be hearing this sound, ping, ping, ping. It's coming from the UPS. Please ignore, forgive me. Right?
Okay, sir.
All right, good.
You understand? Done now.
Yes. All right, thank you. So this interrupt that we are talking about, Madam Ashley, you are saying how different is that from the resource allocation of the CPU, of the operating system. So what we are saying is that the operating system allocates a resource. So this interrupt that we are saying, it could be, for example, when the interrupt is asking the operating system to perform a particular task, then it is the work of the operating system to allocate the necessary resource for the task to be able to be executed. So the operating system will be listening to the CPU. The CPU is what we are referring to right now. The CPU will be idling. So when your screen is sleeping, we are talking about the processor in your phone or on your computer. When your screen is off, when your phone's screen is off, it means that the CPU is idling or it is sleeping, but the operating system is still running. It is still listening. So when there is an interrupt, remember, even though the interrupt comes to the CPU, sorry, the interrupt comes to the operating system, it is the CPU that actually does the work. So the CPU will tell the operating system that I need this resource. Maybe I need a memory space. Then the operating system will allocate that space to the CPU. So both the allocation of resource and the interrupt, they work hand in hand. I don't know if I'm able to explain it well for you to understand. Madam Ashley. Madam Ashley, yes, please talk.
Yes, sir. And yes, sir. I understand now.
All right, sure. Thank you.
Thank you very
You're welcome.
much, sir.
You're welcome. Okay. So now let's look at how the operating system handles interrupt. So the operating system preserves the state of the CPU by storing the registers and the program counter. So as the CPU is executing whatever it is doing, when it is interrupted, so at this stage, when the CPU is interrupted, the operating system will store into a register the current state of the CPU. What is the current state? It will store whatever the CPU was doing. So like I was telling you, if you were playing a music, the operating system will store the current volume of the music, 40%. It will also store the current position of the music file. Maybe you have gotten to timeline 1 minute 32 seconds. Okay, operating system will store this current state so that it will now return the CPU to, it will now take the CPU to the interrupt. After executing the interrupt, control will now come back to the CPU. Then the operating system can now resurrect the music or bring it back to life, making sure it resumes using these parameters. The volume is taken back to 40% and the music is resumed from 1 minute 32 seconds. A typical example is when you are playing music on your phone and you receive a call. You notice that the call will cut. Sorry, the music will stop playing. The call will come in. You will make your call. After you end the call, the operating system will resume the music that you were playing exactly at where it ended. Now, some new phones are coming. They will even take it back a little. So if it ended, if it stopped at 1 minute 32 seconds, it may take it to 1 minute 30 seconds, just so that you can catch a glimpse of what was happening and you have a smooth transition. Okay, so that is what the first point is saying. The operating system preserves the state of the CPU by storing the registers and the program counter. So the current state here, this one that we have talked about, will be stored in the register. What is a register? A register is a memory location. So it will store this in the memory so that it can resume when the CPU gets back on its feet. Okay. Then after it preserves the state, then the operating system will determine what type of interrupt has occurred. So now we are going to look at types of interrupt. Based on the type of interrupt, the operating system will take or will execute the right code. So remember, I was using the storage location as an example. Suppose these are warehouses. We have warehouse A, we have warehouse B, and warehouse C. Okay, so when a request comes, when an order is made, based on the item in the order, we are able to identify which of the warehouses to go. So depending on the type of interrupt, there are separate segments of codes. Okay, there are separate sections that will determine what action should be taken for each type of interrupt. So depending on the type of interrupt, the operating system will determine which of the codes to run or execute. Now, there are three types of interrupts, and I'm going to explain them. We have the hardware interrupt, we have the software interrupt, and we have trap or exception. A hardware interrupt is an interrupt that comes from a hardware. Okay, they are generated by hardware devices. They send signals to the CPU that they need some attention. What is a hardware? What's an example of a hardware interrupt? Maybe your computer will be sleeping and then you press a key. Immediately you press the key, the computer will wake up. That is a hardware interrupt. Or you click on a mouse. That is a hardware interrupt. Or you move your mouse. That is a hardware interrupt. Okay. Any hardware device that is used to interrupt the CPU is a hardware interrupt. Okay. Or sometimes you put in, whilst the computer is still alive, you slot in your what do you call it, your pen drive, and then you notice that the computer will make a sound, boom, telling you that it has detected that your pen drive has been inserted. Yeah, Mr. Enos, you've raised your hand.
Yes, sir, please, I have a question.
Please go ahead.
According to interrupts, you say if you press a key, then the computer becomes active. So what was the CPU doing originally before it got interrupted?
At that time, it was sleeping.
Okay.
Or sometimes even when you are playing music on your computer, it can still go to sleep. You see that the screen is off. When you're playing music on your phone, the screen will be off, but the phone will still be playing the music. So at that time, your computer is playing the music, the CPU is executing the VLC. It is playing the music file. If it's not doing anything, it will be sleeping. Right? Okay.
Okay.
All right. I have people raising their hands. Mr. Stanley, please go ahead.
Hello, sir. I have a question.
Okay.
Based on my past knowledge, I
Okay.
know hardware devices are directly linked to a CPU.
Okay.
So I want to know how the OS come in the explanation you just gave. How are the hardware interrupt?
Okay. All right. So when we say hardware are directly linked to the CPU, I am sure you are saying it from the layman's term. What it means is that when we say, locally, when people say CPU, they are referring to the case. You see, if you take a desktop device, a desktop computer, for example, when we say CPU, we are referring to the case. Okay, the case, you can say computer box, apart from the screen, that box, or apart from the monitor, that box is what we usually refer to as the CPU. But technically, that is not the CPU. The CPU is the central processing unit, the processor inside the case. The CPU is in the case. On the motherboard of the computer is the CPU. So hardware devices are not connected to the CPU, right? They are not connected to the CPU. If you remember from the beginning of this section, I showed you the device controllers. Okay, let me take you back to that diagram. Maybe it will help you to understand it better. If you look at this diagram here, these are controllers. So if you insert a pen drive, you are not inserting it, or it is not being attached to the CPU. The CPU is one unit in the computer system. So if you put in a pen drive, it comes into either the USB controller or the disk controller. You understand? So that is what we are saying. Immediately you connect as a hardware device. If you press a key, the USB controller will inform the CPU with the help of the communication bus that an interrupt has occurred. Mr. Enos, I don't know if I have made things a little more clearer than before.
Yes, sir.
Okay, thank you. Okay, so those are the examples of the hardware interrupt. Then we have software interrupt. An example of software interrupt is what I have given you. Like you are playing your music and Facebook, which is a software, decides to come out with a notification. So whatever the CPU was doing that is playing the music, it will stop and Facebook will interrupt that operation. Another example is when you are playing your music and the phone app, it is the phone app that we use to make calls. When you are playing your music and the phone app, okay, also interrupts so that your music is stopped and the phone comes through. After you finish your call, the music will be resumed. That is also another example of a software interrupt. Then we have a trap or exception. Like I said, these are errors. So if anything happens that is contrary to the original execution of a software, it notifies the CPU. Now, I'm sure you have done Java programming, right?
Yes, sir.
Good. If you have done Java program, then I know you know of this. Exit O. What is the meaning of exit O? What is the exit? And what is the O? What is the O? Exit 0. What does that 0 mean? As for exit, we all know what it means. Yes.
It means that no errors was found.
Very
and
good.
It exited successfully.
It exited gracefully or successfully. The technical term is gracefully. Thank you. So you see, after you have executed all the codes in your, all the instructions in your code, you are telling the CPU, or you are telling your program, Mr. Danny, can you please turn your mic off? Danny man. Thank you. All right. So the exit O is telling the CPU, Danny man, kindly mute yourself. Danny man. Danny man, otherwise I'll take you off because I can't mute you from here. Please, if someone knows Danny, tell him to mute his mic. Otherwise, I'll take him off. All right, thank you. Okay, so exit O means that you are telling the CPU that your program exited gracefully without any error. So when your program exits O, the 0 means no error. It will not send any signal. It will not send any trap. It will not send any exception to the CPU. Any number apart from O, if your program exits 1, it indicates an error, a type of error. If your program exits 2, -1, -2, all the other exit modes are errors except the 0. So if your program, like I was telling you about the when you're on WhatsApp and it automatically exits or closes, it will send, before it exits, it will send a number, maybe -1, maybe -2, maybe 2, maybe 1. It will send that number to the CPU, and that CPU will know that that interrupt is a trap or an exception. When that happens, the CPU knows what to do. It has to do damage control. It has to, recoup the memory that was allocated to that program. It has to bring in the next, if there's any program that is waiting to be executed, it has to bring it into. So all these are traps or exceptions, and it's also falls under interrupt. So these are the 3 types of interrupts there are. So in an examination, if I ask you to explain the types of interrupt with examples, I am looking for live examples like I am giving you, because every time I create a scenario, I give you live examples, live scenarios. So I expect you to also give me live scenarios when you are answering questions of that nature. I'm not saying this will come in an exam, but I'm just, making a passing comment. Are you with me? Are there any questions?
Yes, sir.
Okay. So now, someone will ask, what is the importance of interrupt? Why did the developers of operating system, why did they introduce interrupt? Interrupts are very important because they give the user better control over the computer. In the absence of interrupts, then your computer will run a program without listening to you. If your computer goes to sleep, if there was no interrupt, and there is no way you can wake your computer up. If your phone screen goes off, there is no way you can wake your phone up if there was no interrupt. Okay, without interrupt, a user may have to wait for a given application until its completion. So if you are playing music, for example, and a call comes, your call cannot cut through, right? If you are playing music and your Facebook, you get a message on Facebook or WhatsApp, the WhatsApp cannot notify you because any process that is running has to finish before the next process can happen. So interrupts are very, very important concepts when it comes to the operating system. And so we will devote more time to the interrupt later in this course. All right. If there are no questions, I'm going to clear the screen and move on. Good. So this is a cycle for the interrupt that we have talked about, just to explain the cyclic movement of the interrupt. So we have one starts from here. This is the CPU and this is the IO controller. What is the IO controller? It could
Hello,
be
sir.
Yes, please.
Yeah, I want to ask a question.
Okay, Philip, please go.
About the interrupt importance that you were saying.
Okay.
So let's say the machine freezes. Meaning there's a problem with the interrupt.
Yes.
Okay.
It means that at that time, the CPU perhaps is performing an action that allows no interrupt. And that is why when the device freezes, it will not accept any input. So it is a good question. When a system freezes, it means it is no longer accepting interrupt. Something has happened to the interrupt routine service. And that is why sometimes when you are a computer science student, after learning all these, you don't have to worry your phones and your computers too much when they are not responding, because behind the scene you know you have a clear picture of what is happening. So you just wait for your phone to to have its own time, or better still, you can just turn it off. Don't be tapping the screen, phone freezy, phone freezy, phone freezy. Now you know what is happening. So don't be troubling your phone like that. All right. Thank you for that.
Okay, sir. Last question.
Yeah, please go ahead.
So can it be repaired if it's done for long?
If the interrupt?
Yes.
Yes.
Can it be repaired one way or the other?
Yes. You see, sometimes the interrupt occurs because the CPU is busy.
Okay.
The interrupt occurs because the CPU is busy. You see, we will come to that later on. But you see, the processes that execute on the CPU, they have priorities, right?
Yeah.
So even though the CPU can be interrupted, not all processes will allow interrupt because they have high priorities. Okay, so if a process with a high priority is executing and an interrupt occurs, okay, the CPU will not mind it. It will not allow it to execute because what is executing currently has a high priority. Let me give you a typical example on priorities. You see, when you're doing WhatsApp call, you notice that when a normal call comes through, it will cut through your WhatsApp.
Yeah.
Yes, that is because your normal call has a higher priority. Thank God the light is back on. That is because the normal call has a higher priority over the WhatsApp call. If you're making a WhatsApp call, sorry, if you're making a normal call and somebody calls you on WhatsApp, it will not come, right?
Yeah.
Very good, because the normal call has higher priority than the WhatsApp call. So it is the same thing that happens sometimes when your phone freezes. The phone will be executing a high priority task, and you may want to, cut through, and that will not be allowed. I hope that is clear. Mr. Edmond.
Yes.
Okay, thank you. Mr. Edmond, your hand is up.
Hello, sir.
Yes.
Speaking of the interrupt, I was asking, will memory also be a factor? Assuming maybe when one particular program is running and there's an interrupt, but the machine freezes because maybe that particular program is taking much of the space.
Yes.
So would they, in this case, the interrupt might not be able to stop the current process and start a different one. And that I feel that maybe that too can cause a freeze. Or
yes. Thank you. Thank you very much. That is also true. So let me take some time to explain that. Now, assuming you have a memory, a RAM of 2 GB, okay, your phone or your computer's RAM is 2 GB. I'm not talking about the 150, the 128 GB, the 64 GB, and all that. Your RAM is usually 2 GB, 4 GB, 6 GB, 8 GB, in that order, 16 GB. That's the maximum I have seen. Okay, on phones anyway. Okay, so suppose your phone has 2 GB. You are playing a game. A lot of these games, they occupy, let's say you are playing the Temple Run. Temple Run, maybe let's assume the Temple Run is 2 GB. So it has covered all, or it has used up all the RAM on your phone. That means there is no room for any other program. Then whilst you are doing your Temple Run, another application decides to come in to interrupt. Maybe a phone call, maybe a WhatsApp notification. You see, there has to be a space on the RAM for this new application to run. But because your phone's memory is taken up by the Temple Run, the new application will not get space. Therefore, the Android or the iOS or the Windows operating system has to now find a way to make room for the new interrupt. So what sometimes happens behind the scene, the Android operating system will now be parking the Temple Run to be moving it away from the memory and making room for the new interrupt. Sorry. And at that time, the phone will freeze. At that time, the phone will freeze because the memory is full. The operating system is trying so hard to make some room for the new application. At that time, because the memory is full, the computer or the phone will freeze. Nothing else can work because the operating system, the memory is full. So like I was saying, sometimes when your phone freezes, don't trouble it. Just wait because the operating system is doing something. And that is also why it is very, very important to buy phones with higher RAM, higher memory capacity. Now, if you are going to buy a phone or a computer, look for a phone that has a memory capacity not less than 4 GB. As a computer or as an IT personnel, get something that is higher in terms of the memory capacity. Don't look at the beauty of the phone. Don't go for the popularity of the phone, but go for a phone that has higher capacity in the RAM. Okay, very good. I hope that is clear. Mr. Nicholas, your hand is up.
Yes, sir. Good evening, sir.
Yeah, good evening.
Please, I wanted to ask, since time and date keeps running on every phone, every computer. Please, where would that want to be categorized?
Come again, time.
Yes, time and date. You know, they keep running.
Time and yes. Okay, time and date. Okay, thank you.
Yes.
They also occupy space on the RAM, on the computer. That time and date is a software. It's a software that is running on the computer that is ticking. Okay, so it uses the clock on the computer hardware, okay, to actually, you know, do its job. It is also occupying a space on the computer RAM. So if you have 2 GB all the time, you will not have 2 GB free. Most of the time you may have 1 GB, because a part of it may be used, will be used by the operating system, and the time and date is part of the system's programs that we talked about. Okay, the time and date is a system's program, so it is part of the operating system that has been loaded onto the main memory. So if the operating system is taking 1 GB of your RAM, the time and date is part of the 1 GB RAM. Mr. Nicholas, is that okay?
Yes, please. So it doesn't mean that even when the phone is off, you know, and then you switch it on back, the time will, you know, keep on running at, you know, you have your time correctly, even though the phone went off and came back on.
Yes.
So does it mean that software has been programmed in such a way that even if the phone is off, it keeps running?
Okay. All right. Thank you. So there is a battery in the computer system called the CMOS battery. I'm sure you have all heard of the CMOS battery.
Yes, sir.
Yes, sir.
Good. That CMOS
Yes, sir.
battery, yes. So the CMOS battery doesn't go off. Even when you turn off your computer, it stores the state. It stores, so that is where this time and date is stored. It is the CMOS battery that stores, so even when you turn off your phone, that CMOS is still maintaining the time, so that immediately you turn your computer back on, the time and date application will return the date from the CMOS. That is why on most of the computers, if the CMOS battery goes wrong, you will see that every time you turn on the computer, you have to set the date and time, because the CMOS is not there to keep the time for you. Please, is that okay?
Yes, sir.
All right, thank you.
Sir.
Good. Okay, so moving on. Now, look at the I/O structure. We are saying that when the CPU is executing and it encounters an interrupt, it stops what it is doing and transfers control to the interrupt vector where the service routine is, and it is executed. I hope we still remember that. Now, that is done in one of two fashions. So there are two ways that the CPU handles an interrupt or an I/O request. Okay, this input output are nothing but interrupts. So in the first fashion, when the CPU is executing, okay, and the CPU is interrupted, when an I/O request is made, what the CPU does is that it returns control to the I/O. Remember this diagram. Let me go back to this diagram. This is an I/O device. At this point, the CPU is executing. When an I/O request is encountered, at this point, the CPU will return control to the I/O, okay, and it will wait for the for the I/O request to finish its execution before it resumes. So here, the CPU does no other job whilst the I/O is being executed. That is the first fashion. Then in the second fashion, I'll go back to that slide, but I'm using this diagram to explain. That is the first fashion. In the second fashion, when the I/O request is encountered, the CPU will send the request to that I/O routine. and it will not wait. It will continue its execution. If at this point the IO finishes its execution, then it will come and inform the CPU that I have completed. Then the CPU will do whatever it has to, maybe return the results to the user or do some computation with it. So in the first fashion, the CPU will wait for the IO to finish its execution. In the second fashion, the CPU will not wait. Once it sends the IO, because the IO is a different controller on its own. It's not the CPU that is going to execute the IO. Remember, we have the IO controllers. So if the CPU encounters an IO request, it will send the request to the IO controller. Let the IO controller do its job. Then the CPU can continue with other jobs. Once the IO is completed, the IO will inform the CPU that I am done. Then it will come back, do whatever it has to do, and then continue with its job. These are the two fashions. Now let's go. So that is the first one is after an IO starts, control will only return to the user program upon the IO completion. That is the first fashion. Okay. Here, the wait instruction will idle the CPU. When we say the CPU is being idled, it means it is not doing anything. So it will tell the CPU to wait until the next interrupt. What is the next interrupt? When it comes to tell the CPU that it has finished its execution at this point. Okay, so that is the first one. Okay, so here there is a wait loop. There is a wait loop. That means from time to time, the CPU will be waiting, will be checking if the instruction or if the IO has finished its execution. And here, at most, at every point in time, one IO request is outstanding. And there cannot be simultaneous IO processing because the CPU is waiting. So you cannot have more than one IO being executed. Then in the second fashion, the control will return to the user program without waiting for the IO to complete. So it is very efficient. So at this point, the CPU encounters an IO, it will send it to that. It will continue to execute. Then another device or another process can send an IO, it will send it. It will continue executing. If this one finishes, it will prompt the CPU that I have finished. It will come and do whatever it has to do and then continue. If this one finishes, it will also come and prompt the CPU. And the CPU will do whatever it does. Okay, so here the user program will continue without waiting for the completion of the IO. Now I'm saying that when the IO completes, it will go and call on the CPU. When this also finishes, it will go and call on the CPU. That call is what we call the system call. Okay, it is called the system call. We will talk more about system calls later. It has started raining. I hope my internet connection is okay. Can you hear me clearly?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Very good.
Yes, sir.
Very good.
Yes,
Thank
sir.
you.
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Good.
sir.
So the operating system will index these IO, operations, the IO request, the IO release, and all these system call. There is a table called the device table, the IO device table. This IO device table will have entry of all the IOs that are executing in the computer system. So if this guy is giving an IO, it will be entered here, the state of the IO, what it is doing, and all that. Okay, so the operating system will take control of this IO device table and enter them appropriately so that it can track the progress of the various IOs in the system. So that is the two fashions of the IO structure in the computer system. I hope that is clear.
Yes, sir.
Good. All right, so let's go to the next one. That is the storage structure. The storage structure. I think that this will be the last topic if we don't have much time. Otherwise, we can go on to the next one. I think. Fine, that is good. So the storage structure, let me quickly go through this. So we know that the CPU, that is the central processing unit, will only execute, is the only one that executes instructions in the computer system. Anything that the computer does, as you are hearing me, my voice, as I am moving the mouse, everything is being processed by the CPU before you can hear me. Whether you believe it or not, it is the CPU doing the job. Now, the CPU will only take instructions from the main memory. You know that the CPU will only take instruction from the main memory. So any program that must run or that must be run has to be in the main memory. Simple as that. Like, so you were asking about the date and time. For the date and time to run, that application must be in the main memory. So the main memory is the only large storage media that the CPU can access. The only large, that is to tell you that there are other storage media in the computing system that the CPU can access. Okay, some of these, we have the registers. It is also a storage media that the CPU can access. We will see that very soon. We also have the cache. Okay, the cache is also a storage media that the CPU can access. But the largest of all is the main memory, that is the RAM. Okay, the random access memory. Main memory is implemented in a semiconductor technology called the dynamic random access memory, that is the DRAM. If you're going to buy a computer, they will tell you the DRAM. What technology are they using? They will tell you the DRAM. Okay, and that is what they mean. It's the dynamic random access memory. Okay. Because the read-only memory cannot be changed, only static programs are stored there. So in our main memory, all the programs that we want to run, like your Microsoft Word, will be copied in the main memory. After you close it, it will be erased. That part of the main memory is erased. Then a new program comes. If you are playing a game, the game is copied into the main memory. Okay, then it will play. After you close the game is cleared from the main memory. But we have the read-only memory, which cannot be cleared. Okay, so this read-only memory, we store only static programs like the Bootstrap. Okay, EEPROM cannot be changed frequently, and so it contains mostly static programs as well. That means we have the read-only memory, and then we have the electrically erasable programmable read-only memory. This somehow can be erased, but it is not that simple. The firmware, that is what you do. Those of you who have Android, I'm sure you know that you can root your device. If you have heard of Android rooting.
Yes, sir. Yes, sir. And we can jailbreak it too.
Very, very good. The jailbreaking and the rooting. It has to do with erasing the EEPROM. When you root your Android, it means you are converting it from a mobile device to a complete computer. You want to now use your phone as a complete computer. That is what we call the rooting. The Android, the software, that is the Bootstrap, that is stored in the EEPROM, is what you are technically trying to erase and install a new one. So you are erasing the Bootstrap and you are trying to put in an operating system, or you are erasing the Android operating system, and most of the time you are trying to put in a Linux or Unix operating system. That is called the routing. You can read more about routing. Remember that when you try it, there is the possibility or the likelihood that you crash, you spoil your phone. If you don't know what you are doing and you want to root your Android device, you spoil it. So that is actually what goes on. Then we have the hard disk drive, the HDD. These are rigid metal or glass platters that are covered with magnetic recording material. Okay, the disk, the hard disk surface is logically divided into tracks. So if you have not seen a hard disk before, this is how a hard disk looks like. There are tracks in them. Oh, I'm sorry. Let me clear the screen. They don't overlap. Let me try and see if I can draw. So this is how your hard disk looks like. These are tracks. They don't overlap. Okay. These are called tracks. And the tracks are further divided into sectors. So they'll be divided into sectors like this, like that. And data are stored in these sectors. So if you have a movie, the movie will be stored in this sector. It doesn't go around like that. Okay, they are stored in the sector. Then the next one will be stored here. Next one will be stored there. If this sector is free, is full, then it will come here, there, in that order. So if you have an old computer whose hard disk is almost failing, you will hear when the computer is reading data from the hard disk, you hear that is trying to read the data from here. It goes back and forth like this, reading the data. So that is the noise that you hear. It means it's time to change your hard disk. Masa, go and change it. All right. Okay. Now there is a disk controller. Remember, we talked about disk controllers. They determine the logical interaction between the hard disk drive and the CPU. Some of these hard disk drives are non-volatile, meaning that when you turn off the power to this hard disk, the data on it are not lost. Unlike the main memory that is volatile. When you turn your phone, when you turn the lights off, when you turn the power off from your computer, any data on the main memory is lost. That is why when you are running a phone or when you are running an app and your phone freezes or it is shut down, it goes off, when you turn it back on, you will not see your game. You have to go and run it again because it is in the main memory. But when you install your application on a hard disk drive, if you turn off your phone and you turn it back on, the application will still be there because it is stored in the hard disk drive. It is called non-volatile. Okay, there are various technologies that ensures the non-volatility of our memory drives. Those are beyond the scope of this class. Okay, now this is something for your eyes only. 1 kilobyte is 1024 bytes. 1 megabyte is 1024 kilobytes. Look at the index here. 1 gigabyte is 1024 megabytes. 1 terabyte is 1024 gigabytes. 1 petabyte is 1024 terabytes. Now there is a tendency when people hear 1 GB, there's a tendency to think that it is 1000 megabytes. It is not just 1000, but it is 1024. That 24 should not be forgotten as a computer science, as an IT engineer. You should always know that 1 GB is equivalent to 1024 megabytes. So this is just for your reading pleasure. Let's go on. Now, these storage devices can be categorized based on their speed, the cost and their volatility. Ignore this. These storage devices are categorized in hierarchy of speed, the cost, and the volatility. Let's look at this diagram here. These are the storage devices. I've told you about the registers. We have the cache, we have the main memory, we have the non-volatile memory, we have hard disks, we have optical disks, and we have magnetic tapes. Okay, now look at this. Here, the storage capacity of register is very small. The amount of data a register can store is smaller. A cache can store a little more than the register. The main memory can store more than the cache, in that order. So each level stores more than the upper or the predecessor. When it comes to the speed, registers are the fastest memory you can encounter. Next comes the cache. Next is the main memory. So in terms of speed, the register is the fastest, and then the magnetic tape is the slowest. Now, if you group them, the register, the cache, and the main memory, they form the primary storage. Then we have the non-volatile memory. We'll come to that. These are pen drives. These are memory sticks. These are memory cards. These are external hard drives, and then the hard drives. These form the secondary storage. Then we have the tertiary storage, which are the optical disks and the magnetic tape. So this is a diagram that summarizes the hierarchy of storage devices in terms of their storage capacity, their access time, and their level. So the primary storage are volatile memory. The secondary and the tertiary storage are non-volatile. Okay, good. Now, coming back, we know, I'm sure you have heard of SSD technology. SSD, computers that are coming into the system with SSD. Have you heard of SSD?
Yes, sir.
Yes, sir. Yes,
okay.
Sir.
Do you know what they are?
No. Yes.
Okay, so
No, sir.
So they are chips.
They are chips. Is it the plantain chip or the banana chips?
No, that's
Or
say the small
Medium.
memory chips that they sell.
Please, can I say they are icy?
Okay, they're ICs. Okay, all right, thank you. So yes, of course they are chips, but what type of storage are they? Yes.
Secondary.
Secondary storage.
Yes,
all
sir.
right, thank you. So why is it that computers with SSD are that expensive? You know, if you get a computer with SSD, it's quite expensive. Why is that?
Because they are faster and power efficient. They are faster and power efficient.
Okay, they are faster and power efficient. Yes. Who else? Yeah. I want any.
Because it's a new technology, so for some time it will be expensive.
It's a new technology. Okay, thank you. Yes, Mr. Andrews.
Yeah.
You want to say something?
So they are faster. They are faster and they cannot be easily crashed.
They cannot be
like
easily
the hard
crashed.
drive.
Like a hard drive. Okay, Nicholas.
Yeah.
So because
yeah,
they are more advanced.
Because they are more advanced. Okay. Miss Ashley.
Sir.
Okay.
They are more efficient.
They are thin compared to the compared to the hard disk. Yeah.
Okay, so they are thin and they are more efficient. Okay, guys, thank you all.
The SSD uses flash-based memory.
Flash-based memory. Okay.
Yes.
Thank you. Okay. All right. Very good. Good. Thank you all for your contributions. They are all in good faith. Good. Now, let me take some time to explain the SSD technology for you to understand. So we have said that, you know, storages are used to store data. The SSD is a non-volatile memory. When you turn off your computer, if you have a hard disk in your phone, in your computer or even in your phone, when your phone goes off, your hard disk goes off. Okay, whether it's a HDD or a SATA. When you turn off your phone, the hard disk goes off. They only come on when you turn on your computer. So remember the stages in the booting of your computer. So when you turn on your computer, the Bootstrap will load, then it will go into the hard disk and load your operating system. So by that time, your hard disk is off. So when you turn power on, the hard disk also begins to spin. Now, the SSD technology, these are hard disks, all right, but they have inbuilt memory. They have inbuilt batteries in them that can store the state of the hard disk. So when you turn off your phone, when you turn off your computer, the hard disk is not turned off because of the battery in the hard disk, that is the SSD. So the state of the hard disk is stored. That's why it is called the solid state disk. The state of the hard disk remains. So immediately you turn on your computer, you see the hard disk will just bam, and your Windows will load. So it takes less than a minute for your for your computer with SSD to load, because the hard disk doesn't go off. There is a battery in the hard disk. When your computer is off, that battery stays on. It's like the CMOS battery. All right. That is why it is expensive. It's a new technology. And everything that you say is also true. It is a flash-based, it is a new technology, and that is why it is expensive. So if you get a computer with SSD, your computer is very fast, and this is what is making it very, very fast. Okay. All right. Thank you. I'm going to skip this and go to the general I/O operation.
Hello, sir.
Yes, please.
I have a question about the SSD.
Please go
So let's say I have a computer with HDD and I want to change to SSD.
Yes.
Is it going to be faster?
Yes. It's number one, before you can change your computer from HDD to SSD, the computer must have a slot. It must have the provision for SSD, because the SSD technology is different. And someone was saying they are thin. They are very thin because the SSD is not bulky like the HDD. It's like a chip, very, very tiny. That is slotted in. And so if your computer was not designed, if there's no hardware slot, there's no slot for the SSD, you can't use it, right? That is the first thing. And number two, if you are able to, of course, nowadays, some of the computers that are coming, they have slots for both the SSD and the, the HDD or the SATA. So if you convert your computer from HDD to SSD, your computer will be faster.
Okay.
Yes.
Thanks.
Like I have a Lenovo here that has the SSD slot and also the HDD. The SATA. I don't have money to buy the SSD, so currently I am using the SATA. When I grow old and I get money, maybe I'll try the SSD. For now, I'm using the SATA. If I'm able to buy the SSD and put it in, then the computer will be faster than it is now. Simple. But I don't think it is necessary from where I stand. Don't worry. I want my hard disks to go off when I turn off my computer. Thank you. But you hear na medicasa. Yes, car. Yes. Stanley. Uh-huh.
So please, I have a question on the XSD. Do they have a special way of compressing files? Because most SSDs are 250 gigabytes, and I feel it's too small. So
Yes.
is there a special, how do they handle file storage? I don't know.
Okay. They just, thank you. They handle the files just as the usual HDD does. There is no special compression technology. It's because of the technology, in the making of the SSD. If they make higher capacities, it will be expensive. Remember, you see, they are flashes. Someone said it's a flash drive. The technology they use in making that storage device is more expensive. And therefore, if they make higher capacities, they may be too expensive. Even now, last time I went to ask for 100, is it 120 gigabytes, or is it 60, or some small, storage space, and the price was like 500 Ghana cedis. Why would I buy 500 Ghana cedis? That is less than 100 gigabytes. When I spend 200 Ghana cedis, I can get a SATA drive of, let's say, 500 GB or even 1 terabyte. Okay, so it is just the technology that is making it expensive. And is it because of the expensive nature, they can't make it in bigger quantities, in bigger sizes. Otherwise, people cannot afford. That is why for now, it is in smaller sizes. But of course, there are bigger ones. People who have money can afford bigger ones, and those are the people who are using them. Otherwise, the ones that come to Ghana, that is 120, maximum 120, you get 50, you get 60, you get 40, 20, and all that. You understand? If you have the money, you can request for a higher capacity and you get it. It's all about money. Have you get?
Okay, sir.
Very good. Please, any other question?
Sir, please, on the same SSD.
Yes.
Yeah. So since you said it is always on, it use a battery.
Yes, sir.
Always is on. So
yes,
don't you think it will affect its lifespan?
No, that is a technology. It's like the battery in your car. The clock in the car. It is always on. It's like the CMOS battery on the computer motherboard. It is always on. You understand?
Okay.
So
sir.
yeah, so that is the technology. Of course, there may be drawbacks, but for now, it does not affect the performance.
Okay, sir.
Okay, thank you. So now we have talked about these device controllers. If you remember the diagram that I went to, we have the CPU and then the other device controllers like the disk controllers. Let me go back to that diagram. This one here. Okay, so we have let me clear this screen. We have all these the disk controller, the USB controller, the graphics adapter controller. So we say that they are all communicating using the system bus. And that is why if your CPU cannot communicate with them, then you have to install a driver that will be able to communicate with the CPU. The operating system has to create drivers for these controllers so that they will all speak the common language. So a driver is nothing but a set of protocols that will understand how they communicate. And that is why when after you do your operating system installation, you have to install the drivers. I'm sure some of you, those who have installed operating systems before, you know that after your installation of the operating system, you must install the drivers. The drivers, they serve as the language with which all these components can communicate. Okay, that is what is here. To start an I/O operation, the device driver will load the appropriate registers within the device controller. Okay, the device controller in turn examines the contents of these registers to determine what action is to be taken. And the controller starts the transfer, blah, blah, blah. This is English. When you get it, you can read it. We don't have much time. Computer system architecture. Let me finish with this one, okay? Do we have more time? Or we should close?
Yes, sir. Yes, sir.
Yampoana.
Ah, yes, sir. Phobia winning, yeah, phobia winning.
Close at night.
Okay, so welcome back from the break. Okay, so let me. I was going to tell you about the computers with single processors and multiprocessors.
Okay, sir. Then let's do it. Let's do it.
So let's finish with that, okay?
Yes, sir.
Okay.
Yes, sir,
So
sure.
Good. Let's look at the computer system architecture. Now, you know, a computer will either have one CPU or more. Okay. So the most of the systems that we use today, okay, are single processors. Okay, like we have in the olden days, they will give you some R1, whatever processor. It is just a single processor. Pentium 2 is a single processor. Pentium 3 is a single processor. Pentium 4 is a single processor. Okay, on a single processor system, there is only one main CPU. Okay, so this is a CPU. That processor is called the CPU. This CPU is capable of executing a general purpose instruction set. Okay, so forget about the English. On a single processor, there is only one CPU. Okay, even though there is only one CPU, that means that is the one that is going to take care of all the execution of instructions. It is going to get tired. So even though there is one general purpose CPU, there are other special purpose processors, okay, that can sometimes take the burden of the main CPU. So for example, this is the keyboard special purpose processor. So if there's any keyboard processing, the CPU will relegate that to the to the keyboard. Maybe this is the camera processor. If there's any camera activity, the main CPU will relegate that task to the main CPU. So these are special purpose CPU that are there to support the main CPU. It does not make it multi-processor system. It is still a single processor system. We are referring to the main CPU. Okay, they come, so today, most systems have other special purpose processors. They come in the form of device-specific process, such as the disk processor, so that when there is a need for any disk processing, the CPU will give this to the disk processor. We have the keyboard processor. When there is a need for any keyboard, excuse me, any keyboard operation, the CPU will give it to the keyboard. We have the graphics controller processor. When there's a need for any graphics, the CPU will relegate that to the graphics. Okay, the operating system cannot communicate with these special purpose processors. So the operating system is dealing with the, excuse me, the operating system deals only with the main processor. Okay, if there's a need for scheduling, if there's any instruction, the operating system will send it only to the main processor, and the main processor will now communicate with these special purpose processors. The use of special purpose microprocessors is common, and it does not make a single processor computer a multi-processor computer. The fact that you have these special purpose processors does not make this computer a multi-processor computer. The focus is on the general purpose CPU. So if there's only one general purpose processor, then the computer is a single processor system. I hope you are with me on that. Okay.
Yes, sir.
Good.
Yes, sir.
Okay, let me move. Let's go to the multiprocessor system. That is a computer with multiple processors. That means if we go back to this diagram again, if we come back to this diagram again, we are looking at a computer that has more than one CPU. So this is another CPU here, okay, that is connected. So the operating system communicates with these two processors, this CPU. That is what the operating system does. That is a multi-processor system. Okay. They have two or more processors in close communication. These multi-processor systems are also called the parallel systems. Those of you who have heard of parallel processing, it's because they have multiple processors in them, or sometimes it is thread. We'll talk about that later on. These multiple processors share the same computer bus. They share the same clock. They share the same computer memory. And they share input-output devices. All other devices are shared among these multiple processors. The multiprocessor systems have three main advantages. One, increased throughput. What is throughput? If one processor can do a job in 4 seconds, if one processor can do a job in 4 seconds, then if you have two processors, they will do the same job in 2 seconds, right? Right? Are you with me?
Yes, sir.
Yes,
Good.
sir.
Yes, sir.
Yes, sir.
Okay, if you have three processors, then it will do the job in 4 divided by 3 seconds. Okay, so that is the increased throughput. The amount of job that can be processed is increased. The second is the economy of scale. Now, if one computer, a single processor computer costs 200 Ghana cedis. If I buy 2 single processor computers, how much am I spending? 200 plus 200 is equal to 400 Ghana cedis. These are 2 different computers with single processors each. If I'm buying one computer with 2 processors, with just one computer, but having 2 processors, this will cost me somewhere 250 or 300 Ghana cedis. So economy-wise, this is more prudent. That is the economy of scale. Why? Because they are all using the same bus, they are using the same clock, they are using the same power, they are using the same everything. If you bring it to this one has its own bus, it has its own clock, it has its own peripheral devices. This also have a different clock, a different memory, different peripheral devices. So this in turn becomes more expensive than when you put multi-processors together. The next one, the next advantage, which is the last one, is the increased reliability. If you have more than one processor, suppose I have 2 processors in my computer. If one processor goes off, the other processor can take over the job and do it to a successful end. If there is only one processor in my computer and that processor goes off, then that is it. The computer is dying or is dead. So there is reliability when it comes to multiprocessor systems. Okay, good. Now, there are two types of multiprocessor systems. These are the asymmetric multiprocessor and the symmetric multiprocessor. What is the asymmetric? In the asymmetric multiprocessor, or the asymmetric, of course, depending on the school you attended. Suppose this is one computer with 3 processors using the asymmetric configuration. One of the processors acts as the master, then the rest will act as slaves. So this is slave 1, this is slave 2. Even though there are 3 processors, one of them will act as the master processor. The operating system will usually communicate only with the master processor. If there is any job, the operating system will allocate the job to the master processor, and then the master processor will in turn allocate the jobs to this slave based on their availability. The master processor schedules all the master processor schedules and all, let me close this. Excuse me. The master processor schedules and allocates work to the slave processors. Okay, that is the asymmetric multiprocessor. Then we have the symmetric multiprocessor. In this case, there is no master slave. They are all bosses of their own. There are 3 processors here. They are all bosses. The operating system will allocate job to any of the processors that are available whenever there is a new job. Okay, so here there is no master-slave relationship. Okay, so look at this diagram. It is very important to consider where to put the memory when it comes to multiprocessor architecture. Okay, based on the location of the memory, we can call the arrangement the NUMA or the UMA. The UMA is the uniform memory access, and the NUMA is non-uniform memory access. That is, if you look at these 3 multiprocessors, look at the distance from CPU 0 to the memory and the distance from CPU 2 to the memory. Compare it to the distance from the CPU 1. Remember that memory, the RAM is very important when it comes to the position, because the CPU takes instruction from the main memory. So the distance from the main memory to the CPU is very, very crucial. If you have ever opened a computer system before, if you look on the motherboard, the main memory is always close to the position of the CPU. It is never far away. The distance, the physical distance is very important because the CPU takes instruction directly from the main memory. Okay, so in the multiprocessing architecture, the location of the main memory is very crucial. Okay, now let's go to the multi-core processors. This is quite interesting. I'm sure you heard of Pentium 1, Pentium 2, Pentium 3, Pentium 4. Then after the Pentiums, they started with the dual core. That is when the multi-core processors came in. So we have dual core processor, core 2 duo, quad core, and all that. That is another technology. This is also a multiprocessor, but this time, instead of having these processors on their own, that means here, if you look at the motherboard of this computer, there will be 3 physical locations for the processors. You have physical location for processor 1, physical location for processor 2, physical location for processor 3. And then you have maybe the memory, the main memory somewhere here. This will be the physical arrangement for these multiprocessor computers. Now, in the multi-core processors, you have cores. The CPUs here are called cores. Okay. You have the cores. These are the CPUs. But instead of having all of them at, as separate processors, they are put on a single chip. So here you have one chip, okay, that has two CPUs. So you have two CPUs embedded in one chip. What is the advantage here? Here, if you compare this to this, here there's a lot of distance between the two processes, or between the three processes. If they have to communicate, of course, they have to do everything in what do you call it, in agreement. If there is a job, they have to decide which of these must take over the job. Okay, and that communication incurs time overhead. That communication incurs time, and in computation, time is very important. So in order to kill that, they decided to bring the two, or the CPUs on one chip, so that the distance between them becomes very short. They can communicate very fast. Another point is that if you look at this one here, this CPU must have its own power. So if this one is 5 volts, and that is also 5 volts, and that is also 5 volts, if you put together all these volts, the processor alone is consuming 15 volts. But if you come to this multi-core, these two processors are on the same chip. So that chip alone will take 5 volts. If you have 3 CPUs, you still have the chip consuming only 5 volts. So they are more efficient than multiple chips with single cores, because on-chip communication is faster. If the chips are on one, if the cores are on one chip, communication is faster. In addition, one chip with multiple cores usually significantly uses less power than multiple, like I have told you. These multi-cores appear to the operating system as N standard processors. Even though they are all on the same chip, the operating system still sees them as 3 individual processors. So it doesn't make any difference. The technology is only to store or to save resources, to make the use of the resources in a judicial manner. Okay, so that is the multi-core processor. Now, there is a, what do you call it, pressure on the designers or the developers of the operating system. Why? Because now they have to design the operating system in such a way that it can make efficient use of these cores. In the olden days, they had only one processor. So when you are designing operating system, you don't have much header. But now there are 3 processors. Therefore, you must design the operating system in such a way that it can make use of all the available processes efficiently. And this is also the reason why the newer technologies, the newer computers will not accept the old operating systems. For example, the computer I am using currently will not allow me to install Windows XP, because Windows XP was designed for single, a single processor. Okay, and so Windows XP will not be able to function well on my computer because there are 3 processors. It will underutilize the processor on my computer. Therefore, it will not allow it. Neither can an old computer accept Windows 10, because Windows 10 was designed to optimize the use of multiple processors, and the older computers usually have single processors. Okay, now, before I end the class, let's talk about the I technology, i3. I'm sure you have heard these computers with I technology. So from the dual core, from the multi-core processors, they came to the I technology. So we have I3, I5, I7, I9. I haven't heard of I12 or I11. The maximum I've heard is I9. Okay, so technically, these I technologies are supposed to have equivalent processes. So I3 means 3 processes. I5 means 5 processes. I7 means 7 processes. I9 means 9 processes. That is how it is supposed to be. But over some time, they have realized that if you put too many cores on one SIM or on one chip, assuming you have 5 CPUs on one chip, these 5 CPUs will have to communicate among themselves. If there's a job, for example, they have to decide which one will take it. They have to coordinate. If you give it a software or a program, the program is divided into processes. The processes are shared over the processes, and they will process them. They have to do this in communication, in close communication with each other. That communication incurs an overhead. Hey, so if you want to do something among the group, it takes time, because when you are doing something that involves a lot of people, but all right, that is what it means. If you have multi-core, or if you have a lot of processes on a single chip, the communication overhead is too much. And so the i5, most of the i5s and even the i7s, they have just about 2 processes. Some of them have only 3 processes. Instead of i5 having 5 processes, they end up having 3. I'm using an i5 computer that has only 2 processes, but it is an i5. Okay, I know of a friend who has i7 that has only 3 processes. Okay, so even though they are saying i7, you may think there are 7 processes. They're lying to us. Not lying, but I mean, it's not possible. You understand? So that is the I technology. Now, in the student portal, I have this lecture note uploaded there. You can download it. There's also an article on the multi-core processes. You can read. It will give you more information on the I technology. Okay, and then there's also an article there that you can use to verify how much processes your computer has. So go and follow it and verify how many processes your computer has. Okay.
Okay, sir.
Good. There are others, but I think it's time we should close so that you can sleep.
God bless you, sir.
Okay, sir. Thank you. God bless you.
So we will end the class here. Enjoy the rest of your evening. Good night.
Okay.
You
Thank you
too,
very much,
sir.
sir.
Thank you.
Have a good
Bye.
Thank you.
Sir,
Your class was very
thank
Thank
you. We
you.
are tired,
Class
man.
was good. Class was very good.
All right.
The
Thank
class
you.
is nice. Yes.
All
thank
right.
you.
Good night, guys.
Good night.
So I am.
Sir, can we have the video?
Yes.